Hi, everybody. We're going to continue our lesson on linear equations, but today we're going to focus on writing linear equations using the coordinates of 2 points that are on the line. Before we did this lesson, remember, we learned how to write the equation given a slope and a y-intercept. We learned how to write the equation of a line given the slope and 1 point on the line. Today, we're going to focus on the coordinates of 2 points. So if we have the coordinates of 2 points on the line, how do we write the equation? Remember that we're going to be writing our equation in slope-intercept form. So that's y equals mx plus b form. And there are two things that we need in order to write the equation in slope-intercept form. We need the slope and we need the y-intercept, okay? But this time, instead of me giving you the slope, which is what I did last time, you have to algebraically find the slope given the coordinates of 2 points. And that's going to require you to use the slope formula, okay? We've looked at this before. This is the slope formula. M equals y minus y over x minus x. And those little subscripts just tell you that that's the second y and the first y, and that's the second x and the first x. But it actually doesn't matter the order that you do the y's and the x's as long as the order is consistent between the 2 points. So that's how you find the slope. Now, once you have the slope, you can do what we did last time with replacing the slope and the coordinates of 1 point and solving for b algebraically. Today, we're going to put those two parts together to eventually write the equation of the line. And what I've done here is I've made this box which shows you the steps for writing the equation using 2 points. I'll walk you through the steps right now, and then we'll take a look at a few examples. Step number 1, find the slope of the line using the slope formula. There's that slope formula again. Step number 2, we're going to choose one of the points that were given, and we're going to use that point's x and y value. Then, for step number 3, this should start to look familiar, we're going to replace the y value, the m, the x value, into y equals mx plus b. And step number 4, we're going to solve that algebraically for b. Lastly, we're going to write the final equation replacing the m that we got in step number 1 and the b that we got in step number 4. We're going to look at 3 examples, and they will increase in complexity only because in example 2, for instance, we have negative numbers, and in example number 3, we have fractions. But the complexity might increase, but the procedure stays the same. So let's take a look at example number 1. What's the equation of the line in slope-intercept form that contains the points 2, 6, and 4, 10? So remember step number 1 said, use the slope formula to find the slope. Now, I want you also to remember that the coordinates of every point represents an x and a y. And that first number is an x, the second number is a y. So we have 2 of them. X is 2, y is 6, and x is 4, y is 10. So what we're going to do is use the slope formula in step number 1 to find the slope of the line which contains those 2 points. Now, remember how it said y minus y. So on the top, we're going to do 6 minus 10. And on the bottom, it said x minus x. And because I started with the 6 for the y, I have to start with the corresponding x for that point. So I have to start with the 2. So the bottom will go 2 minus 4. A little simplification, we get 6 minus 10 is negative 4, and 2 minus 4 is negative 2. Reducing this down as far as we can go, we have a negative over a negative. That's going to be a positive, and 4 divided by 2 is 2. So the value of m is equal to 2. Step number 2 says to choose one of the points and as an x and a y value. Now, if you're looking at a set of coordinates like this, right, if you have a choice of which point to use, I'm going to give you a little advice. You're always going to want to look for the one that seems the simplest to you, okay? So if, for example, if there's fractions, you might not want to use that point. Or if there are negatives, you may not want to use that point. Sometimes you don't have a choice, but you should always use the ones that you think are simplest to use. for me, those tend to be positive numbers and small numbers. So today, I'm going to say that we are going to use the point 2, 6 as our x and y value. So for step number 2, I'm going to write down that x is equal to 2 and y is equal to 6. All right, now step number 3 says replace the y, the m, and the x values into y equals mx plus b. All right, so I'm going to write down y equals mx plus b. And now I'm going to replace the y with 6, the m with 2, and the x with 2 to solve for b. So I get 6 equals 2 times, and notice I'm putting my x value in parentheses. That's to help me remember that I need to multiply. And then b stays as b. In fact, you know what? Maybe we'll choose a different color to remind us that b has to stay b. All right, so how do we solve? So step number 4 says solve for b. Well, we're going to multiply our m and our x together. So we get 6 equals 4. There's plus b, right? And we're going to subtract. We want to isolate b, so we're going to subtract the 4 from both sides. And if I do that, I get 2 is equal to b. Lots of 2's floating around here, huh? Okay, now notice what I did. In step 1, I put a box around m. And then in step 4, I put a box around b. Those are the two pieces that have to come together to form my equation, right? Now again, remember, it's y equals mx plus b. And in step number 5, we're going to write the final equation just replacing the m and the b. Y gets to stay y, x gets to stay x, but we're going to replace the m with 2 and the b with 2. And so we get y equals 2x plus 2. This is the equation of the line which contains the points 2, 6, and 4, 10. Now that was a fairly easy example only because they were all positive numbers and the numbers are fairly small and you got integers. But let's take a look at another example. Okay, this time let's include some negative numbers. That way you can see the arithmetic that goes along with that. All right, so we're writing the equation of the line which contains the points -1, 3 and 4, -7. So remember step 1 says we're going to find the slope. Now, if you want to, you can say xy, xy. I like to do that just to remind myself of what I'm actually looking at. So the top is y minus y. So we have 3 minus -7. And then on the bottom, we have x minus x. So we have -1 minus 4. All right, so some simplification. 3 minus 7. 3 minus a negative, right? 3 minus -7. So when we see minus minus together, remember that's plus plus, because subtraction is the same thing as adding the opposite. 3 plus 7 is 10. And then -1, take away another 4, is going to be -5. So simplifying 10 over -5 is -2. So -2 is my slope. And there I put it in the box, right? There's step number 1. Step number 2, we're going to choose one of the points as an x and a y value. Now, if I look at these 2 points, let me head over here. None of them seem any simpler than the other, although -1, 3 might be a little bit simpler because the numbers are a little bit smaller. So let's go ahead and use that, okay? Remember, step number 2, we're going to say x is equal to -1 and y is equal to 3. Now in step number 3, we're going to replace the x, the y, and the m into y equals mx plus b. So I'm going to write y equals mx plus b, and now I'm going to do some substitution. So y is 3 equals m is -2. So we have -2 times x, which is -1. And then remember, in this step, plus b gets to stay plus b. Little simplifying, 3 is equal to, now negative 2 times negative 1 is positive 2. So we have positive 2 plus b. And then we're going to subtract 2 from both sides to isolate b. And we get 1 equals b. I'm going to put that in a box. Now that I have m and b, I'm going to go ahead and I'm going to write my equation replacing the m and the b. So y is equal to negative 2x plus b, which is 1. This is the equation of my line. So that's what happens when you have negatives, okay? Remember, when you subtract a negative, that's the same thing as adding a positive, so you get plus plus. Please, please, please be careful with your signed numbers here. If you need to use a calculator, please do that, okay? I'm not opposed to people using calculators. If you want to just double check and make sure that 3 minus negative 7 is 10, by all means, use the tools that you're given. I do want to look at one more example though, okay? Because sometimes the numbers that we get aren't all that lovely, all right? Sometimes you get fractions, but let's not freak out, all right? Don't worry, it's not that bad. We're just going to have to remember what we learned back in like 4th and 5th and 6th grade about dealing with fractions. So here are my 2 points, negative 2, 4, 3, 6. Let's find the slope. M equals. So again, if you want to do xy, that's a good thing, okay? So it's y minus y on the top. So that's 4 minus 6. Now on the bottom, we have x minus x, or negative 2 minus 3. So 4 minus 6 is negative 2. Negative 2 minus 3 is negative 5. All right, so the only thing we can really simplify here is the negative over a negative. Negative over a negative is the same thing as a positive. So I don't know about you, but I would rather work with positive numbers. So I'm going to change that to positive 2 over 5. And that's my slope. The slope this time is 2/5. It has a rise of 2 and a run of 5. All right, now which point are we going to choose? Negative 2, 4. Or 3, 6. I think I'm going to go for 3, 6 because they're positive, okay? So what do we do with that 3, 6? Well, remember in step number 2, we say, okay, well, x is equal to 3 and y is equal to 6. Now we get to substitute the x, y, and m into y equals mx plus b. Y equals mx plus b. A little substitution gives us 6 equals 2/5 times the x, which is 3, and remember this step, plus b, okay? So simplifying and isolating b. Now, 6 is equal to 2/5 times 3. What's 2/5 times 3? Well, what I like to do is I like to change this 3 into a fraction by putting it over 1, okay? So you end up with 2/5 times 3 over 1. And now you can multiply straight across the tops and straight across the bottoms. All right? Now that's going to give you 2 times 3 is 6 over 5 times 1 is 5. And then we still have our plus b. All right. Same arithmetic. So now we just got to subtract 6/5 from both sides. And sometimes I like to look at fractions when I work with fractions more like this. 6 minus 6/5 equals b. Okay, I like to see it horizontally instead of vertically. It kind of makes more sense to me that way. All right, so one number is not a fraction, but the other number is a fraction. What we need to do in order to subtract them is we need to make sure that they're both fractions with the same denominator. So how do we change the number 6 into a fraction with 5 as its denominator? Well, remember that 6 is the same thing as 6 over 1, right? And if we need to change the denominator to a 5, then we need to multiply it by 5. And if we multiply the bottom by 5, we got to multiply the top by 5. That's how we change a number into a fraction. So 5 times 6 is 30. 5 times 1 is 5. So 6 is the same thing as 30 over 5. And 30 over 5 minus 6 over 5 is 24 over 5. So 24 over 5, now I don't think we can simplify that. 24 over 5 is our b. Last thing we need to do is to rewrite, or to make sure we write the equation, but we're going to replace the m and the b, okay? So y is equal to 2/5 x plus 24 fifths. This is the equation of the line. So again, this example was a little bit more complicated because you had some fractions to work with, but hopefully you caught what arithmetic I did and some of the strategies I used in order to find b, right? Okay, so what you're going to do now is you are going to take a minute and you're going to just go back and take a look at what we did in these 3 examples, 1, 2, and 3. And then you're going to do some practice on your own. I put the practice in the Schoology folder. Please, please, please do the practice. Check the practice with the answer key that's provided. If you have any questions after you've done the practice, please contact me. That would be the time that I help you, okay? And then lastly, there's an exit slip in the folder. I would love for you to do that by the end of class or before the next class. If you have any questions along the way, please contact me. I'm available all day, and I get back to people pretty quickly. So have fun, and we're almost done with school, so let's keep our fingers crossed that everything works out well, and have a great day.